If a single nanoparticle could sense a spike in inflammation and light up like a beacon, you spot an impending flare before it even starts, and deliver a tiny dose of steroid directly to the inflamed cell. Picture this: you tweak the surface protein, loading each nanocarrier with a fluorescent pad. It cruises through vessels, evades immune patrol, then dots at the inflamed artery. A quick pH shift opens its lid. Boom! Payload released, collateral damage zero. If you could program a swarm of microbots to patrol your gut, each one carrying CRISPR scissors aimed at harmful E. So, you send in the bots via an oral capsule. They unzip, deploy sensors, identify a toxin signature, snip the offending gene, then self-destruct. The result? A living pharmacy inside your microbiome shaping itself in real time. No broad-spectrum antibiotics, no resistance pricing. If you could 3D bioprint an organ on 8 chips that mimics a patient liver with perfect accuracy, you seed human hepatocytes, add microfluidic channels, housing nutrients and oxygen, and suddenly you've got a tiny liver on glass. You drop a candidate drop on one end and watch metabolic byproducts flow out. Toxicity flags light up in milliseconds. You iterate doses on your laptop before you ever touch a rat. Think of the time you save, the lives you spare. You're in the lab. You hold the clear vial. Inside, RNA strands fold into hairpins designed to hijack viral replication. But these strands aren't random. They're powered by AI that scan millions of viral genomes overnight. If tomorrow, your code could predict a mutation that spikes infectivity, you forestall the next pandemic by designing a preventive therapy before the first patient coughs. Imagine synthetic enzymes that slip through the blood-brain barrier, correcting misfolded proteins in neurons of Alzheimer's patients. If you could tap these enzymes with a peptide sequence that mimics natural transporters, they hitch a ride on cellular trucks and unload right inside brain cells. Once inside, they reforge amyloid chains back into harmless monomers. Memory restored. Now fast forward to personalized medicine. You sequence a patient's genome in hours, map out SNPs in drug metabolizing enzymes, and tailor a chemotherapy cocktail that maximizes tumor kill while sparing the heart. If you knew exactly how CYP450 variants clear each compound, your dosing chart will be a work of art. No guesswork, no dose, limiting toxicity. Here's the kicker. All these ifs are edging toward reality. You've seen the papers on lipid nanoparticles, the clinical trials on gene editing, the organ chip startups bursting onto the scene. Each breakthrough is a puzzle piece. And you, as a graduate student, hold the clue. Your next experiment, your next grant proposal to fuse these ideas into a revolution. So ask yourself, which if? Will you chase the nanobot sentinel, the microbiome engineer, the AI-driven RNA sculptor, the organ-on-a-chip artisan? The choice is yours. Dive in, disrupt the status quo, and write the next if that changes pharmacy forever.